Hello, my dear students. So, in this lecture, we will know about the properties of S matrix for E-plane. And as we know, the E-plane is considered as the uh, three-port T-junctions. So there is a three-port, as you can see here. So it is one of the. There are three type of planes in T-junction. T-junction means which have three ports right there. There may be four ports for hybrid, but there's three ports: E plane, H plane, and EH plane. And here you can see that for E plane T junction, an E plane T junction is formed by attaching a simple waveguide to the broader dimension of a rectangular waveguide, which already has two ports. The arms of rectangular waveguides make two ports called collinear ports. So these two ports are collinear arms, and that is not the collinear arm, that is the E arm. It is if it's a series T. If it's not a series T, if it is perpendicular to the collinear arm, then it will be H plane. So in that particular case, if an E-plane T-junction is formed by attaching a simple waveguide to the broader dimension of a rectangular waveguide, which already has two ports. The arms of rectangular waveguides make two ports. This rectangular waveguide has two arms, as collinear arms, port 1 and port 2, and port 3 is called as side arm or E arm. His E-plane is also called series T, as the axis of the side arm is parallel to the electric field. The junction is called E-plane T junction. This is also called voltage or series junction. The ports 1 and 2 are 180-degree out of phase, which each other. The cross-sectional details E-plane T can be understood by the following figure. So it's 180-degree shift between these two collinear arms. For the E plane, it's known as a series junction or voltage junction, as the E arm, as in perpendicular to the collinear arm. But that is the thing of the basic idea of the E plane T junction. Now, so that is the S parameter calculation for E plane. As we know, there are three planes, three ports. So these three ports will make 3 by 3 matrix. That means each and every part of the matrix equation shows that which arm, which power, and which type of part is being transmitted through which arm. If you get this type of things, this S11, as it is the first, as you know, it is the first element of this 3 by 3 matrix. So it will just give you an idea that it is a port only for one. So this diagonal matrix, that's for S11, S22, S22, and S33. So these ports are the self ports. That means if you just refer to S11, it's defined as in the same port you are just communicating, or you're just giving the power in the same port, 1 1, and 1 2 2 1 3 1 3 2. These are the mutual ports. Okay, so for 1 2, that means that will transfer from 1 to 2. Okay, from 2 1 means 2 to 1, that the power will transfer from 2 to 1. That means this. And if you get a 1 3 3 1, that means 1 to 3 and 3 to 1. So 1 to 3 and 3 to 1, these ports are 90-degree apart. And for the collinear coefficient, collinear means simple E plane T, that means 1 3. If you say 1 3 and 2 3, so for these two ports, it is 180-degree shift. So you can write S23 is equal to minus 1 S13. The port is perfectly matched. If a port is perfectly matched, the port will be the power of the port will be 0. Okay, if the port will be perfectly matched, then no power will come through here. It will come if any leakage of power happens. So for that particular case, no leakage. If no leakage happens, it is perfectly matched, means this port and this port will be perfectly matched, so there will be S33 will be 0. Another thing is that there may be S23, S13, whatever else, but there will be no power in S3. That means there is no power is applied through the third port. So if you don't apply any power in the third port, in self port, the 3 number terminal, so it will be perfectly matched junction. From the symmetry property, we can say some of the properties, as you can say from the symmetry property. So just look at it, the equation number 4, that is the Sij Sji. What does it mean? 1 2 and 2 1, 3 2 and 2 through 3, 1 3 and 3 1 are the same. So for this we can include some of the things, as you can see here. Now considering the 3 and 4 equations that we have taken before, that 2 3 is equal to minus 1 3 as 180 degree shift, 3 3 will be 0, and other mutual corresponding port numbers will be exchanged with each other. So you can write like this. We can say that we have 4 unknowns. That means there are really 4 unknowns: 1 1 1 2 1 3, 2 2, and okay, so yes, 1 1 1 2 1 3 and 2 2. There are 4 unknowns considering the symmetry property. So from the unitary property, we can write that each and every complex conjugate and its parameters, if it multiplies with each other, it will generate a it will generate a diagonal matrix. What type of diagonal? Unit diagonal matrix. Okay, there is a unit diagonal matrix, as it is known as a unit matrix. It will generate a unit matrix, and if we multiply after just calculating these two things, we will find out that from first row and column, from the second row and column, from the third row and column. So there are some equations right there, and all the equations are equal to 1 if we just calculate it through the whole calculations journey. So we can find it out. Now the thing is that after calculating the equations from the equating the equation from 6 and 7, there are 6 and 7 numbered equations. If we equate these two equations, if we just equate this equation and this equation, so we can find out this S11 is equal to S22 as equation 10, and after that 2S13 square, S13 is 1 by root 2, and all other things will go further. S11 is equal to half, and other things there. And there is substituting the values from the above in S matrix. We get just like this. After calculating all the values of S matrix, we get these values. So you have to prove this when you are writing some of the questions, that what are the S parameter calculation of E plane T. So you should write this. And there is some known unknown facts. We know that the B1, B2, B3 is half 1 by root 2. So these type of things are also important in that particular portion. So thanks to all.